Hello everyone, this video is for reviewing KSAT math problem whose admission year is 2024. KSAT stands for Korea Scholastic Aptitude Test. Aptitude Test. So this is exam for someone who wants to admit university in Korea. On this video, I'm gonna specifically deal with the required math problem, order type problem 21. This is about interpreting the graph of f of x and interpreting the new function of g of t. Okay. In this case, we have two domains here, which is separated in the point of x equals to 6, and I have a full equation of function f of x for the domain x is between -1 and 6 here. So I'm gonna draw the full graph of for this domain here. And by the way, this quadratic polynomial for x is between -1 and 6. -1 is included and 6 is excluded. Specifically here, this is a quadratic equation, so I can manipulate this equation by this, and by adding proper value 9 here, and I add the 9 again because there's a minus sign, so this is actually -9 plus 9, they are cancelled out. So for that, I have minus x minus 3 is quantity square plus 9. So that means it has a symmetry axis, x equals to 3, and also it has its maximum value 9 here. So the graph looks like this, and also this graph passes through the origin. You can check when x equals to 0, it becomes to 0, and its boundary value when x equals to -1, the value of f of -1 is -1 minus 6, right? Which is -7 here. -7. What I'm missing, also I can take a limit, lower limit, x goes to 6 from below here, and its value of f of x is, since this function is continuous, this is 0 because negative 6 square plus 6 square is 0. So the limit value of f of x when x goes to 6 from below here, the value of f of x takes the limit value 0. So the whole graph looks like this and this for the domain x between negative 1 and 6. Okay. And also what I have for the domain where x is equals to 6 or greater than 6, this is a log graph whose base is 4. So this is an increasing function whose asymptotic line is x equals to 5 here. Okay, and then when x equals to 6, its value is 0 because log of 1 is 0. Okay, so actually this is not continuous and there's a 5 here. The log graph will goes to negative infinity, but in this case we only have its non-negative part. It will look something like let me draw like this one. Okay, the second point for this problem is the meaning of g of t where t is non-negative. G of t is a maximum value of f of x on the closed interval whose length is 2, closed interval. Left ending point is t minus 1 and right ending point is t plus 1. T is the middle point for this interval. Okay, so for instance, when t equals 0 and the interval is from negative 1 and positive 1 here. So for this region from negative 1 and positive 1, what's the maximum value for f of x? Let's compute the value of f of 1 minus square root of 1 plus 6 will be 5 here. So the maximum value is 5 here for this region, this interval. Okay, so in this case g of 0 is 5. Okay, and by the symmetry of quadratic function, g of f of 5 is also 5, will be also 5. And since this logarithmic function is also increasing, so there's some value of x like q here, such that f of q, which is 8 times log of base 4 and q minus 5 will be 5 here. There will be some value q. Q is greater than 6, obviously. And this function g of t is defined or non-negative t, because the function of f of x is defined for the x which is equals to -1 or greater than -1. So this is a left end point for the function of domain of f of x. So this is fine, and f of x is continuous on the domain which is equals to -1 and greater than -1. And the condition for g of t is I want to maintain its minimum value as 5 here, and this value 5 takes place when t equals to 0. Okay, and for the whole non-negative value t, I want to satisfy this inequality. G of t is equals to 5 or greater than 5 here. So for instance, for the region say g of 1 here, this is the maximum value of f of x x is from 0 to 2. Okay, from 0 to 2, the maximum value takes place at x equals to 2 here. So f of 2, if you compute, -4 plus 12, which will be 8 here. Okay, and so on. You can keep doing this for the closed interval whose length is 2. You can figure out the maximum value of f of x on that interval. And what's an issue here, until this interval, and for this interval will be fine, and when the left ending point for the interval is 5 and right ending point is 7, so that means the middle point is 6, there could be an issue because this value of q, but the 7 can have, f of 7 can have the value which is less than 5. So let's focus on g of 6 here, which is maximum value of f of x on the closed interval from 9 to 7 here. Okay, and let's say here the right ending point 7, f of 7 is this value, base 4, 7 minus 5, which is log with base 4 of 2, which is half of a, because log with base 4 of 2, which is 1/2. Okay, so if this value is less than 5, I mean for the case when this 7 takes place here, bigger than q here, and on this case if we take the closed interval from 5 to 7 and we move this closed interval from t minus 1 and to t plus 1 here, each maximum value will always be this f of t plus 1, and in this case it will also equals to or greater than f of 7, which is half of a, okay, which is bigger than 5. But when this value is less than 5, let's take a look at this case, why this should not be the case. When the value of f of 7 is less than 5, so the 7 will be positioned here. This is a q value. F of q is exactly the 5, the value 5 here. Okay, and then the g of 6, which is a maximum value on the closed interval from 5 to 7, will be 5, because f of 5 is 5 here. But you can move a little bit close, little bit bigger, move t value little bit bigger than 6. Okay, let's say this one, this much. Okay, and here let me be more specific. Let's say this q assume this q value is 7.1 here. Okay, so this is a 7.1, and if you think the value of g of 6.05 here, which is a maximum value of f of x on the closed interval 5, 0.05 and to 7.05 here. Okay, and the maximum value for this case is either f of 5.05 or let me say like this, the maximum value between two values, between two ending points 5.05, f of 7.05. Okay. However, those two values, f of 5.05 and f of 7.05, which is less than 5, so this maximum value is less than 5. This is one of those two values. Okay, so maximum values happens either this value or this value, and since both of them are less than 5, the value of g of 6.05 is less than 5, and that's the problem. Okay, this is not the case. So at least the value of f of 7, which is half of a, can be 5, equals to 5, or should be greater than 5. Okay, so this is our final condition for this problem. Requires you to figure out. Okay, let's wrap up this problem. This problem, the point of this problem is graph of f of x, and luckily even though the domain is separated, the whole graph of f of x is continuous. This makes our life more easier. And then new function g of t is defined as like this, maximum value on a closed interval. Okay, and you have to figure out the meaning of the function g of t on the graph of y equals f of x. That's the whole point. Okay, that's it.